Let's talk about Newton's third law. So in the past, when you learn physics in IGCSE, you may have learned this already, and something that you may focus on is you may heard that it is something called like action and reaction pair, which they have the equal magnitude. That's one thing, and they have opposite direction. But in IB, that is not enough. One thing that you should also notice is that they should be on two different bodies. So in that case, that means if object A exert a force on B, then B will be exerting the force on A instead. And the relationship, as said, it will be equal in magnitude and opposite in direction. So let's take a look at some examples here. You can see here in the textbook, it said when there's a person pushing the wall, then the wall is also pushing her in opposite direction. So imagine somehow you're on the roller skate, you simply push the wall with a force. And in that case, apparently from our usual experience, you get pushed back as well. And that is because of the action and reaction pair, that if you push the wall with say 3 Newton, then you also actually get pushed by the wall with 3 Newton in the opposite direction. But I don't quite like this picture, as in on the right hand side, this one. Once you leave the wall already, then you are no longer pushing the wall, right? So I don't actually like putting an arrow here, because by that time you already have no force already. You may have some maybe velocity if this is really smooth, like there's no friction, but then this may be quite misleading. So remember, when the force is removed, so say this force is gone, then the force acting on you is also gone as well, because once again they are action and reaction pair, so they both exist together or they both vanish together. So what about friction then? In the previous video we talked about friction earlier. So what is the action and reaction pair for the friction then? Let's just simplify the case, as in you are walking. For example, say this is the ground and this is you, and as we said in the previous video, when you are walking forward with the velocity forward, let's say, what you do actually is your feet is pushing the floor backward, so that you have a forward force with friction, right? And that is how you kind of propel yourself forward. So my question is, what is the pair, what is the other force of this friction acting on your body? I'll give you some time and think about it.
A few moments later.
Okay, let's talk about the answer. Before we think about the answer, we should firstly think about, so for this friction, it is exerted by who and experienced by who. Okay, so in this case, for this force that I was just talking about, it was exerted actually by the floor and experienced by the person, right, or yourself. So then according to the Newton's third law, it should be the opposite when you talk about the other pair. So it should be the force that is exerted by the person and then experienced by the floor. And so the answer is actually, when you only focus on the floor, then there should be a friction with the equal magnitude. So let's say this is say 10 Newton, then you should also have a friction that is acting on the floor, which is exerted by the person in the same magnitude, so 10 Newton in the opposite direction. So that in fact actually means you are kind of rolling the earth in the backward direction, if you think about the big scale. Because if I try to draw the earth and say this is you, of course this is not in scale, but then if we only focus on the earth, then that is this friction right here, okay, and that is going in the backward direction with 10 Newton, right, while yourself is moving forward with that friction. So then in fact, if you try to think about this in another kind of scale, it's the same as those circus. You may see some clown kind of walking on the ball forward, and then the ball kind of roll backward like this. So it's the same idea. Of course, you don't realize you're kind of rolling the earth forward, because that is not only you affecting the earth, and also the mass of the earth is much more massive than you, so it's not noticeable. Let's take a look at another example. So think about this. When there's a person that is simply standing on the floor, and well, what you may say about it is, say this is at rest, then you may say, oh, for the free body diagram, you may draw this as has a weight, and there's normal force or reaction force, or I would like to call it normal force actually, will be acting on the person. So the question is this normal force or reaction force as a pair of the weight? Think about it. Okay, the answer is actually no. Okay, and in IGCSE, quite many people thought they are the action and reaction pair, because you may think the weight, okay, let's say for a 70 kg people, then that would be 700 Newton, and the normal force will also be 700 Newton, and you may see, hey, they are the same magnitude and opposite direction, so shouldn't it be the action and reaction pair? You have to be careful with the logic here. When you see something that is opposite direction and equal magnitude, doesn't mean they must be the pair. But for the pair, then they must be in the opposite direction and equal in magnitude. So it's the same logic as apparently your mom is a woman, but it doesn't mean that all women will be your mom. And not to mention, if you refer to the statement, it has to be in two different objects once again. So back to here, you will find the two forces, the weight and the normal force, are actually acting onto the same object, which is yourself. So they are apparently not the action and reaction pair. So let me ask you, so what are the individual pairs then? Pause the video, think about it, and continue afterwards.
Imagination.
Just like the previous example, what we have to think about is, so what is the other object that is related to the force other than this person? So first of all, for the weight, let's talk about this first. It is the force given by the earth acting on the person. So if I try to draw the diagram, so once again, this is the earth, again, not in a very good shape and in a good scale. But then the person would then experience in this picture the weight with 7 Newton once again. At the same time, the person is in fact pulling the earth with the same amount of force, which is also, we also call it weight, and that is 700 Newton towards the person from the center of gravity of the earth. So these two will be the action and reaction pair. Think about this: if somehow earth vanish, then of course there's no weight, then both weights would disappear at the same time. So what about the other force, the normal force then? And think about this, that will be similar to what we have in the previous example, that is the friction, because this normal force is given by the floor. So once again, the action and reaction pair of this normal force acting on the person will be the force that the person giving to the floor in the opposite direction, that means downward, and in the same magnitude, so 700 Newton as well. So this one and this one will be the action and reaction pair. We can even counter argue the statement that originally I said the weight and the normal force acting on the person will be the pair. So you can think of a way to counter argue that by thinking, is there any scenario where you only have one of the force only? Think about it. The case is actually very simple. When, say, you are jumping in the mid-air, say, well, maybe I draw here. So say you jump, okay, and maybe your hand is up also, okay, jump, okay, I try my best to draw. And in that case, think about the force acting on your body. You will still have the weight on your body, but then there's no more reaction force, because apparently you are away, you are not even touching the ground anymore. So obviously these two, the normal force and the weight of the person, cannot be the action and reaction pair. Here is another example from the textbook with a helicopter. So think about how helicopter. The reason why the helicopter can hover means that it can kind of stay in the mid-air is that there is a lift force provided by the blade and which counterbalance with the weight here. And so as we said, we already know about the weight action and reaction pair. So what we want to focus right now is the lift. So let's think about what is the action and reaction pair for the lift.
A few moments later.
The reason why there is a lift force for the helicopter is because it is given by the air actually, because the helicopter actually pushed the air downward. So in fact, while the helicopter got the lift force from the air themselves also got pushed down by the helicopter as well. So there's a downward force acting on each air particle, and collectively all these air particle forces add together. You can kind of imagine it as the lift acting onto the helicopter. So these will be the action and reaction pair. There is a very good video from Veritasium, a YouTube channel about physics, and this video is simply about the Newton's third law, and that is also related to rocket science as well. So you can see the water jetpack here. The machine is actually pumping the water down, so the water is experiencing force that is downward. At the same time, the water is acting a force to the person and of course the machine as well upward, and that is the action and reaction pair. And by the way, there's a rainbow, and that is some sort of physics we can talk about in another video in the future. And so please try to visit this video. It's a really nice quality, and it will help you understand more about Newton's third law.